Hello everyone and welcome back to this new video on mesh. Today we are discussing about mesh for complicated geometries. I want to talk about why manual meshing is so important, especially when you are dealing with complicated shapes and designs. We all know that meshing is a crucial step, right? In any simulation. It's how we break down our geometry into smaller domains or manageable pieces so that COMSOL can do its magic. While the automatic meshing tool in COMSOL are great and can handle a lot of cases pretty well, they sometimes miss the mark with really complex geometries. That's where manual meshing comes into play. In this tutorial, we'll see how we can use manual meshing, at least the basics of it, so that you get an idea how to use it. For example, even in the geometry itself, this is like the mesh 1, and if you see this mesh, it is slightly simpler, but even this slightest change can save a lot of memory. So if I go back and forth, you can see that mesh 1 is very dense, whereas mesh 3 is slightly less dense. Now you might have a question, why do we bother about manual meshing at all? Well, first off, it gives you a full control over the mesh. You can decide exact how fine or coarse the mesh should be in different areas of your model. For example, here I have added a distribution so that there are actually 10 elements in the circle. Okay, so in half the circle, so there are actually 20 dots or 20 nodes along the whole circle. So for example, if you have region with sharp edges, small holes or thin walls, you can make mesh finer there to capture all those details accurately. On the other hand, in simpler areas, you can use coarse mesh to save your computational power and time. This way, your simulation runs more efficiently without sacrificing accuracy where it matters most. So for example, from this geometry, you can recognize that it is a computer CPU fan, right? And we all know that this is the fan and this is the thermal mesh kind of metal plates that are there behind the CPU fan. And this is the region where we put the thermal paste and actually put it above the CPU, right? And we are trying to model the thermals of this design. So this is from one of the simulations, so I thought why not make a tutorial of how we can actually minimize the computational cost from the mesh. So what I will do, I will just try to show you that what is the problem here. So I will just go on to add mesh, click on add mesh. Okay, now what I will do, I will just click on the build all. So I'll just uncheck this is not needed for now, so I'll click on build all. Now since this is a complicated geometry, it might take some time to create the mesh, and we can always click on progress and check what is going on. So as you can see, the total number of elements, and I got an error. So what is the error? It says failed to generate mesh for domain something, and there is some phase where we have some problem. Okay, so let's see what is the problem. So we'll click here and check what is the problem. Okay, so in this blade, I think it's the size of the element that is causing the trouble. Let's see the other region where I have the problems. So it seems like the problem is with the blades. Now in the blade, what I can think is that the thickness of the blade is quite small, but I need to check what is the element size. So if I go to size, you can see that the minimum element size is 0.0169. So it is chosen by default by COMSOL, and the maximum size is 0.0094. But I think this mesh size can be smaller. So one way To check what is the problem is that by using the measure feature. So what we can do, I'll just add a distribution just to enable the boundary selection. If I click on the sides and then if I click on measure, you will see that it will show the length as well as the edge number. So you can see the length is in the order of 10 power minus 4 meter, right? So you can think that this is quite small and even this region will be smaller. So I think probably the size of the mesh is a factor here. To check that, I'll just delete this for now. I'll just go on to size, and in the minimum size, what I can do, I'll just add 0.05 and I will again click build all and see what happens. But before that, I will just increase this size. So I'll just make it 0.001 and the minimum size 0.0005, and I will increase this to 1.8. That is, the element will grow 1.8 times, and I'll click on build all. Now I will see what is the result that we get. So we'll wait for a few seconds and probably the mesh will be done, so we can always check that in the progress. Okay, so it's showing the number of elements is around 514k. Okay, it's touching millions. Okay, so this is the mesh that we have got, and you can see that there is no error at all. So this is nice. Even if the mesh is fine, at least there is no error. Now here is some exclamation mark, and it says the edge is much shorter than the specified minimum element size. So we need to reduce the element size to maybe a smaller value. But what we can do, we can always improve our mesh or basically reduce the number of element by adding, let's say, distributions. So what we can do, at least we can use the distribution feature in these sites and say that just reduce the number of elements in this region. So I will add 25. Now I'll just do this for the different region. So I'll just add one more distribution, and this time I will choose the longer sides. So again I will make this, let's say, 30. Now remember one thing, that if you choose this side and you just type a smaller number, then there will be an error. Now I will explain what do I mean by that, but before that I'll just run the model with this selection and see what do we get. Or I'll just select few more sides so that we can have all at once. So I'll select this one and this one. Now okay, let's click on build all. Now remember that we had like 1.8 million domain elements, but I'll click on build all again and see what is the result that we are getting. Okay, so if we look closely, the number of domain element have reduced, the number of boundary element has also reduced, and the number of edge elements has also reduced. So what we have done, we have reduced the number of element around some region where it is not necessary. So these are like the outer region where the thermals will not affect much. We are more interested to see the thermals along the edges of these domains. Okay, so this is how you can improve your mesh of your model. Now, as you can see here, since we have selected the distribution along this line, you can see that it is struggling to draw points and then joining with the other boundaries. Now, if we reduce this from 30 to a lower number, then we might get an error. It is because it will check what is the element growth size, and then it will also try to stitch the other boundaries with the boundaries that you have selected, but you are restricting the boundary to just have 30 elements. So you need to be careful while adding the manual control in the mesh. So I hope you get some idea how you can actually improve your mesh quality. So for complicated geometries like this one, I would highly suggest first go with the very fine mesh. It might take a while, and then try to reduce the number of elements by adding distribution, corner refinement, size, etc. For example, you can choose these domain and reduce the number of elements here and so on. So all these things you can try. So I will show you a different mesh that I have prepared. So you can see that the number of elements is quite less here. So if you click on statistics, you will be able to see how many elements are there in this particular geometry. So this is like the default mesh that we generated, and if I click on statistics, it says around 590k elements. Now this is the mesh that I modified to reduce the number of mesh elements, and if I click on statistics, you can see that it is quite low. Now let us select the new mesh and click on statistics, and you can see that it is quite high. So the previous mesh, that is mesh 3, this mesh here I have modified it a lot, and I will show you the settings of this. So here I added a distribution along this circle, and I've added a distribution along this circle, the outer ring as well as the inner ring. Hello everyone, and welcome back to another tutorial in COMSOL Multiphysics. So in this tutorial we will learn about some basic concepts which are vital for creating mesh for complicated structures, so that you don't run with errors, and also you will save a ton of computational time, as well as I will show you few geometry tips so that it might be useful for you. So let's start with a blank model. So I'll click on blank model, and we will have our blank model open, and then I'll just go on to a 2D, because we are working on 2D for this tutorial. So there's a geometry and sketch. So I'll go on to sketch and create a rectangle, just a quick rectangle, because this is just for demonstration. And now we will draw a curved shape in the rectangle. So I'll click on draw quadratic. I'll click here, left click, I'll left click here, and then I'll click here. Then I will right click, click on polygon. So what it will do, it will change from quadratic to polygon. Then I will click here, and you will see that I have a composite curve. Now if I go back to geometry, click on build all object, and if I uncheck the sketch, you see I have the two solids. Now I'll show you a different technique, because when people are beginning to work on geometry, they get confused. So I'll just disable it. Now I will again do the same thing. So I will just click on build selected. Okay, I'll click on sketch, and I'll draw quadratic. So I'll click here, I will click here, and I'll click here. So I have this shape. I will click here and click on Fleece quadratic Bezier. Okay, now if I go back to geometry and click on build all object, you'll see that there is no solid, and sometimes people get confused what is going on, right? So how can we fix this? Now either you can create a geometry properly, like that is for experienced user, And if you are a beginner and you don't want to do it from scratch, the easiest way is go on to sketch, go on to polygon and click here and here, right click, click on finish polygon, and then you have a polygon ready. Basically what it means is, if I disable this rectangle and I click on build all object, you will see that I have this curve and this line, just like previously we had in the composite curve. So you can just select both of them and click on group. Now you have the same thing just like the composite curve. And now what you can do, you can go back to geometry, uncheck the sketch, and you can go to convert to solid, click on the line that is pole 1, so this line, click on the quadratic curve, so QB1, so we have this 2, and note that you should keep check unite object and click on build all object. Now you have the solid ready. And of course you can always go back to sketch and you can click on this dot, and maybe you can change the curvature and so on if you need it. And again you can click on build all object, uncheck the sketch, and you have your geometry ready. So I will enable the rectangle, and then we have this geometry done. Okay, now let's go on to mesh and click on build all. By default COMSOL will create a triangular mesh. So now what we want to do is we want to create a mapped mesh. So just right click, click on mapped, and just click on the domain. Now you have to remember that mapped mesh works well with rectangles, and while if you want to select a curved shape, then if you click on build selected, it will say that a problem occurred, failed to create mapped mesh for domain, entity must be bounded by at least 4 edges. So you can see that it cannot handle the curved shape, because when you select a rectangle and click on build selected, you'll see that it create a nice rectangular mesh. Okay, so this is the first step. And the second step you can do, you can just click on mesh and click on free triangular. You can either select remaining or you can select domain. I will better select the domain and click on build selected. Now you can see that we have a rectangular mesh here and a triangular mesh here, and these are well connected at the interface. Now you might have to work on some problem where you are interested to see the result at the interface, but you see that the mesh is quite coarse, so your results will not be smooth enough. In that case, what you can do, you can always create a distribution. To create a distribution, you can go on to mesh and click on distribution. This is a very useful tool, I think the most useful tool in all of the mesh settings. So just click on the line on where you want to have a dense mesh. For example, I'll click on here and write 50. So what we'll do is that it will create 50 mesh lines here, so that it will have a fine structure. So to understand, I'll just write 5 and click on build all. So probably okay, I did a mistake. So I did it inside the free triangular. I think that is why I'm getting the problem. So I'll just delete this. So I'll click on mesh, I'll click on distribution, I'll put it here, and now I will click, and its number of element is 5. I'll click on build all. So you can see that when I click on 5, there are 5 sections. As you can see, 1, 2, 3, 4, 5. This is how you create a mesh of your choice. Now you can see the other part will automatically adjust itself. So now if I create another distribution, so let's say I'll create distribution inside the triangle. Maybe I'll click this and I'll write 50. I'll click on build all. Now you see that I forced COMSOL to say that create 5 mesh in this boundary, but create 50 mesh point in this outer boundary. So it will automatically adjust itself to create the particular mesh. Okay, this is how it works. Now I want to show you one of the important concept that is generally not discussed. So the arrangement of these functions or these features is very useful. So you have to think what kind of mesh you want to create first. So if you want to create the rectangular mesh first, then put it at the top. If you want to create the curved mesh, then put it at the top, like that. So for example, if I drag the distribution maybe in the middle and click on build all, you see that the distribution doesn't work because the mesh here is already done in the map. So since I have written 5, but you can see there are more mesh here, it is not 5. So the arrangement of the feature is useful. So depending on your priority, you have to put it properly. So I will drag the distribution below the size because size is my first priority. Then I will go on to the distribution. So it will create 5 elements. I'll click on build all. You can see that it created 5 elements. But when I drag it below the mapped and click on build all, it doesn't work. So for example, if I drag the triangular mesh above, you can see that the mesh doesn't work properly as well. You can see that the triangular mesh dominated and then we get some curved mesh. So depending on your priority, you have to set up the mesh structures. So for me, this works fine. Now I have the mesh ready. So one more thing you can do, for example, you want to study a system where you want to tag the number of points with some parameter. So you can always right click on parameter and you can name it density of mesh and click OK. Now if I go on to parameter, you can see that I have the density mesh here. So if I click here, let's say 20, and in the mesh I click on build all, it will automatically create 20 points in the mesh. So this is how you create a mesh density in your model. I hope this tutorial was helpful to you. If it did, do give a like and do share with your friends so that everyone get to understand how the system actually works. So in this lecture, we will learn how to add materials and physics. By the way, COMSOL is smart enough, and if you set the object to be a union object, that is a combination of all the components, then in the material, you can see that it automatically selects all the small sections as a single material. Okay, this is fine. So now let's look on to the physics. Now this is the panel where we set up the physics and the boundary conditions. And in slightly complex simulations, we use global definitions, functions and other parameters which we may link from this physics. So this is the physics we have. We may have to link our variables and functions from the global definitions. So those things are there in very complex simulations, which is not generally required in simplest simulation. Okay, so let's open up the physics panel. Like the last section, we studied how to add inlet and outlet in a simulation. So simply we'll select inlet and select this region as the inlet of a simulation, and this as the outlet. Remember that all the other parameters I have kept constant. As you can see, as in section 1, I selected the average velocity v, and that v is defined in the parameter section. Okay, so what this will do is, now COMSOL will think that this is my input and this is my output. So the fluid will flow in this fashion. Okay, so this is the idea of this model. Okay, so now our basic boundary condition and setup is finished. So we have the wall, that means the fluid will not pass through it. As you can see, we have the wall defined, and we have the outlet and an inlet. Remember that if you have a complex simulation, you can always add symmetry, open boundary, interior wall, and all those things, and you can explore it depending on your simulation. You can also add fluid properties. So if I click on fluid properties, you can see that you can add the fluid property inside this channel to be user defined, viscosity, and all these parameters. Okay, so let's delete this for now because we are not working with this. Great. Now move on to mesh. Let's see how the physics controlled mesh works. We will select finer. No, let's go with normal because we are not interested in the data. We are just learning how to simulate. It will take unnecessary longer time if I select finer mesh. Let's click build all, and here we'll see the magic. We get some warning. Okay, now let me explain what actually happens. Suppose you have a geometry of this kind. Let's say you have a rectangle, okay, and you have some kind of this structure or some kind of like a diagonal structure. Now if you zoom into this region, how it will look? It will look something like this, and the mesh are created something like this with triangles and rectangles and all these things. But as you move close to the edge, it is very difficult for the mesh to make the domain because it has a sharp pointing end, right? So this is what happens with COMSOL. It says that the generated some elements of low quality. It is because, as you can see, that it is very difficult to create a mesh in this domain because the geometry is such that it is too difficult to create mesh. As you can see, it is very thin, right? It is in nanometers. It is so thin. That's why COMSOL is struggling to create a mesh in this domain. Okay, so how do you fix this problem? This is a complicated problem, right? So how can you fix this? Even if you create extremely fine mesh, there will always be a region which is finer than the mesh, and the computer will, or the software will struggle to make the mesh. So how to fix this? Let's learn how to fix this kind of problem. This is a very interesting problem, and many of my students and colleagues face this problem, and I have explained to them this is how you need to fix, especially for 2D simulation. Now with geometry selected, go to geometry, click on virtual operation, and then click on ignore edges. Okay, now select the edges of the domain which are overlapping, such as this one, this, zoom out a bit, zoom in, these lines also, this one, zoom out. Okay, we have pretty much selected almost all the overlapping domains. Now click on build all. You will see the magic. You see, now all the domains are now connected without having the separating lines between it, right? Now if you click on mesh and then click build all, you will see what is the difference. Now you can see a very beautiful continuous mesh along the model, right? So we don't have any error even if you are running a normal mesh. Even if you run a coarse mesh, I don't think, yeah, you see there is no error. There is no meshing problem at all. So, and you can see that if you select physics control mesh, it will automatically think that you are using some kind of a fluid simulation, and the mesh will be made accordingly. As you can see, there are some parallel mesh along the sides so that you can have a better simulation result. So that's it for this lecture. In my next lecture, we'll learn how to run the simulation for this model, and later on we will go through the result, post-processing, and few advanced post-processing techniques. So stay tuned. I hope you are enjoying this course. See you in my next lecture. Thank you.